Alright, so today we are starting our first lesson talking about angles, degrees, and special right triangles. So you can see here lesson objectives would be properties of angles, degree angle measure, 30, 60, 90, and 45, 45, 90 triangles. So here's some basic definitions you need to know in order to be successful in the class, not only for this chapter but for later on. So first we have an angle. So an angle here is two rays with a common vertex. And what you can see here, here's your vertex that's circled in blue. The rays are these two lines extending from that point and then out to infinity in both directions. Another really important topic here is the terminal versus initial sides. There's underlined there for you. That's basically allowing anyone who sees your work in mathematics to know which direction you're measuring this angle, so basically telling you what type of rotation it has. Here, if it's measured in a counterclockwise direction, then you would denote the angle measure as a positive value. If it's clockwise, then the angle measure would be considered negative. And then lastly, you see down here, we have a whole bunch of goofy looking letters, and those are just essentially Greek alphabet letters. I mean, a lot of stuff you'll notice in trig is all Greek based because they pretty much came up with most of your modern day geometry stuff. So this first one here, the circle with the line through it, that's theta with the T. This little fish looking thing is alpha, and that is beta. So if you see those, don't freak out that you have no idea what's going on and that they're crazy math world's trying to get you. It's just how they denote stuff here in trig class. Some other basic definitions that you should know. What a degree measure is. Most of you guys have seen that before. It's what we're used to. A couple things to think about. One complete revolution equals 360 degrees. So if we go halfway around, what would that equal? Hopefully you can figure out that half of 360 is 180. Next, just some geometry review stuff. An acute angle measure is between 0 and 90. A right angle measure is exactly 90. Obtuse, 90 to 180. Straight angles are exactly 180. More stuff that hopefully you remember from geometry class. So here, the sum of two angles add up to 90 degrees, then those are called complementary. If they add up to 180, then they are supplementary. So looking at these following three examples, let's find some complements and supplements. So a complement, what we're trying to do is figure out what would make 20 degrees, 20 plus what would give you 90. And in this case, you just take, 90 minus 20, and you get 70. So a complement is 70. What would the supplement be? Same concept, except supplements we see are adding up to 180. So you would take 180 minus 20 and get 160. Now this guy, 135, well that's way bigger than 90 degrees. One thing you keep in mind is now you're going to start dealing with negative angle measures, and negative angle measures are denoting directions. And so you could end up getting a negative. So if we did 90 minus 135, you would have a negative 45 degrees. And then its supplement would just be 45. Now, theta here, we put a variable in there just so that it's used to denote every situation and whatever angle measures you want to put in there. So to find the complement of theta, as we were doing before, you're just taking 90 minus theta. To find the supplement, we're just taking 180 minus theta. Alright, Pythagorean theorem. Most of you guys have seen this before. One thing, once again, you're just making sure you know that formula, a squared plus b squared equals c squared. This works for right triangles and right triangles only. One of the nice things is the a and the b can actually be switched around. They don't, as long as they're on the leg, meaning that they're a side length that touches the 90-degree angle here, then you're in good shape. C has to be opposite of that. C can't be anywhere. It has to be here on the hypotenuse. Here's your special right triangles that we covered yesterday in class on our worksheet. So just as a review, one thing to kind of help you remember these is opposite side lengths and angle measures are always follow a pattern. The smallest opposite side length, so here is 1, that's the smallest number. It's always going to be the opposite of the smallest angle measure, which is 30. Square root of 3 and 60 are going to be opposites. The square root of 3, I don't remember exactly, I think it's like 1.7, something like that. And then lastly, we have the right angle, biggest angle measure, opposite the largest side length. Same thing goes over here for our 45, 45, 90 triangle. So let's take a look at this example here. So we have a 53-foot wide house as a roof that is in the shape of a 45, 45, 90 triangle. How could we find the length of the sides of the roof and what would they equal? So one thing people tend to get confused on in this example, when we're drawing this picture, we have our house. Here's our roof. How this is supposed to be set up is this is supposed to be a right angle here at the peak of the roof, which means this side length here, that's the width of the house, so that's 53 feet. And if you ever see in math a little apostrophe there next to a number, it's to denote feet. So how can we find the side length? So that means we're looking for that value and that value. And then what would they equal? So I want you to think about that on your own. Try, work this out a little bit tonight, and then we'll come back and talk more about it in class. Alright, next example. So we have a 10-foot ladder leaning against a brick wall, making a 30-degree angle with the horizontal. So with the horizontal is key here. Hopefully we remember horizontal meaning ground. So here's our ground, our brick wall. So the ladder's 10 feet. So we have a 10-foot ladder. So let's draw our ladder here. Dun, 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 dun. We know that's 10 feet. Makes a 30-degree angle with the horizontal. So it's saying 30-degree angle between the ladder and the horizontal, which is the ground. So that's where our 30. Now, what would be helpful is knowing some of these other angle measures. This top angle measure here, don't really know what it could be. However, unless this is a leaning tower wall, we would hopefully know that that's a right angle there. So now you have a 30, 60, 90 triangle with one side length. And so it's essentially just an application of the problems we were doing yesterday. So that concludes the notes overview for today's lesson. Once again, kind of look through some of these examples, try them on your own, bring questions to class, and then we will work on some extra problems during class tomorrow.